All right, you guys, today we're going to complete going over this assignment 1.6 review. We have a test coming up tomorrow, so let's take a look. All right, this part is talking about in this graph, it's basically we're looking at graphical limits, okay? Now you guys look, when it's approaching a number and there's no plus or minus, it means I got to check both sides, okay? So here's -1, that side, they meet up. Doesn't matter if the point's not there. They meet up at 1. All right. When it writes just what is f of -1, that specifically refers to the point at -1. So at -1, the point is right there at 0. Okay. This also refers to the point at 1. So go over to 1, that point is at 0. Okay, so just kind of like reading the graph here. Let's see. The limit as I approach 1. This is a +1, and it's both sides. Well, the right-hand side goes to 3, the left-hand side goes to 0, so this does not exist. Okay? It would have to go specifically from one side or the other in order for us to find it. As I approach -3, okay. Well, here's -3 right here. Left side, right side, they meet up. They meet up at 1. And then this one is asking me to approach 1, which is here, only from the right-hand side. So that one does have a limit. Only from the right-hand side, that goes up to 3. Okay? Now, anytime we're looking at these infinite limits, what that means, that's sometimes called the end behavior of the graph. What's happening at the ends of the graph? The limit as x approaches positive infinity is what's happening on the furthest right-hand side of the graph. Okay? The limit as x approaches negative infinity is what's happening on the very left-hand side of the graph. Okay? So if we look at this, this is going down to approach this line right here, which is at 1. Okay, this is going down to approach this line right here, which is at 0. All right, and then the last one we have here, as I'm approaching -2, this is an asymptote. Now, because they're both going the same way, all right, I am allowed to say that that's approaching positive infinity. I'm also allowed to say it does not exist. So either one of those would be okay, all right? Now, this next part's a little bit tricky, but there is a question like this on your test. All right. So first of all, let me kind of erase this information on my graph. Let's go through and look. Now, the types of discontinuities that I'm looking for are holes, asymptotes, jumps. Okay? And holes are the only ones that are removable, because if I fill in that hole, it's continuous. These are not removable. Okay, so the first thing it says is list all the removable discontinuities. Removable discontinuities basically means to list the holes. Okay, if I go through here, there's one right there. So that's at -1. And that's it. That's the only removable discontinuity. Okay, the non-removable discontinuities, I'm looking for asymptotes, jumps. So there's an asymptote right here. So that's at -2. There's a jump right here. So that's at 1. Okay? All right, perfect. Okay, let's look about continuity when we're just looking at an equation and not a graph. Take a look at this equation right here. The two places where things are going to be discontinuous, basically when I have 0 over 0, which will make a hole, when I have a number over 0, which will make an asymptote. Okay? So if I were to factor this equation down, on the bottom I can take an x out, and I can cross these out. Well, that tells me that there is a hole at 0, because I crossed that out. All right? And I'm left with 1 over x minus 1. That tells me there's an asymptote at 1, because that's what will make the bottom 0. Okay, so that's where it's not continuous. So where is it continuous? I guess we would say -infinity to 0, 0 to 1, 1 to infinity. Because I just have to take out the hole and I have to take out the asymptote. All right. This next question, on what interval is that continuous? Well, the only thing I know about square roots is I can't take the square root of a negative number. So whatever is inside cannot be negative. It has to be positive, or it could be equal to 0. So if I solve that, x has to be greater than or equal to -2 when I subtract that over. So it goes all the numbers from -2 to infinity. Okay? So you're basically looking at where does it divide by 0, or where are we square rooting a negative. All right, perfect. We're going to use this for problems 38 through 44. Sketch a graph. Okay, don't worry too much about that. You're not going to be sketching any graphs on your test. We can do this really quickly. Basically, it splits up at 0 and 2. Less than 0, it's the line x plus 2, which is a line that comes down like this. So I'll just make it go like that, and it's got a point right there. Like I said, you don't have to worry too much about this. X squared plus 2, that's a parabola that goes like that. But we're only doing that parabola between 0 and 2. So it's like, whoops. Basically like that part of the parabola. That's an open circle, and at 2 goes up to 6. And that's an open circle, okay? And then the last part is just the line 2, which means it's a closed circle here, and it just goes that way. So it kind of shows you the jumps and stuff. Again, don't worry too much about that. Now, with these limits and stuff, you can look at the graph, or you can just look at the equation, which is what I'm going to do, okay? In order to see if there's a limit at 0, I've got to check both sides. Well, 0 from the left, 0 plus 2 is 2. 0 from the right, 0 squared plus 2 is 2, so the limit is 2. We can see that because it meets up on my graph right here. Okay, at 2, the limit from the left, 2 squared plus 2, that's 4, 5, 6, that equals 6. And then from the right, it equals 2. Those do not meet up. Okay. But we could get a one-sided limit. Now what this means is 2 from the left. Those are numbers less than 2. I'm going to use this equation, and 2 from the left gave me 6. All right, just from the left. Now be careful about these. The limit as it approaches 1, as long as it's not splitting. It's so weird. Okay, so we're looking at now the limit as it approaches 1. Okay, so what I was saying is if you're looking at this piecewise function, if I have 0 less than 0, 1's not less than 0, between 0 and 2, 1 is definitely between 0 and 2, greater than 2. You just plug it directly into there, but this is the number you guys got to plug in, okay? So I got to plug in 1. 1 squared plus 2 is 3. So simple. So just look at what part of the piecewise function it's in. And then the last part, okay, as x is going to infinity, remember that's end behavior, that's this way. What's it approaching? Well, since that's just a constant 2, it just keeps going towards 2. Okay? Okay?
Okay.
Okay. Great. All right. List all the discontinuities. Guess what? There's only one. There's just a discontinuity at 2. And with piecewise functions, you guys, you really only have to check for discontinuities where it breaks. So like check at 0, check at 2. Okay, but at 0 it met up, so it was only at 2. And it was a jump discontinuity, which is non-removable. It didn't necessarily ask you all that. Okay, let's take a look at 45. All right, it says that this is continuous, okay? If we know that it's continuous and the only spots where it breaks up are at 3 and 1, that's where we're going to have to test it, okay? So I'm going to take, let's start with 1. I'm going to plug 1 in here. That gives me 2. And I'm going to plug 1 in here for the x, right? So that gives me 1 plus a plus b. So I have this equation, 1 plus a plus b equals 2. Or I can subtract the 1 over to make it a little bit simpler. A plus b is 1, okay? Then I'm going to check this one. At 3, I'm going to plug that in. 3 plus 1 is 4. And at 3, if I plug that in, 3 squared is 9 plus a times 3. I'll call it 3a plus b. Okay, so my next equation is 9 plus 3a plus b equals 4. If I subtract the 9 over 3a plus b is negative 5. And then we got to solve these equations. All right. And what I've noticed is a lot of you guys have forgotten how to solve a system of equations. So I'm going to remind you. Okay. When you look at this, you want to be able to cancel out either the a or the b. Since that's plus b and that's plus b, I want to cancel out the b. But in order to cancel it out, it has to be 1 plus 1 minus. So what I'm going to do up here is I'm going to multiply everything by negative 1. Right here, I'm going to leave it the same. So 3a plus b is negative 5. Negative a minus b is negative 1. So I end up getting 2a is negative 6, a is negative 3. Okay, so that's called a system of equations, right? That's the algebra stuff that you have to remember. That's not calculus stuff. That's the algebra stuff. Okay? Okay, then I go back and I plug that into either equation. I'll go ahead and use that one to find b. So it says a plus b is 1. So negative 3 plus b is 1. So b is 4. A is negative 3, b is 4. All right? All right, perfect. Moving right along here. Let me go ahead and factor out the bottom of this. X squared minus 1 is x plus 1, x minus 1. Okay? And when you guys reduce that, that's what gives you a whole. There's a whole at x equals 1. Okay? When I cross that off. The way I can find the y value of the whole is I just take this and I plug it into what's left. If I plug 1 in, it's 1 over 1 plus 1, so it's 1/2. So the whole is actually the 0.1, 1/2. All right? Vertical asymptotes, once I cancel that out, wherever the bottom equals 0. So there's a vertical asymptote at negative 1. That one doesn't have a y coordinate because it's just an asymptote. Okay? So the domain is all real numbers except 1 and negative 1, because that's for my whole, my asymptote. All right, end behavior. Let's go ahead and do that over here. End behavior. End behavior is the limit as x goes to 0, or infinity, I mean. And the limit as I go to negative infinity. Okay, go ahead and let's look at this right here. The degree of the top and the degree of the bottom are the same. This is where you check to see if the top or bottom is bigger or whatever. And they're the same. So I get 1 over 1, which is 1. Same thing's true for negative infinity. So that's the end behavior. Okay? I don't know. You don't really have to worry about a graph too much. It basically looks like horizontal asymptote at 1, a vertical asymptote at negative 1. It goes 0. Let's see here. I believe it goes like this. Like that. And then there's a hole at 1. So there's like a hole right there. Okay?